So here's part D of 2009 Form B number 3. This is on the AB and BC exam from 2009. And part D defines a new function g. And so g of x is defined in this weird sort of way. It's defined as a definite integral from 0 up to x of f of t with respect to t. It's defined on the interval from -4 to 6, and then it wants us to figure out on which intervals is the graph of g concave up, and then explain your reasoning. So I want to focus on this part of the problem first. When is g going to be concave up? Well, g is concave up when g double prime of 0, or g double prime of x, excuse me, is greater than 0, when it's positive. Right? A function's concave up if its second derivative is positive. Right? Remember our little sketch, second derivative positive, you're concave up. So we would need to be able to determine the second derivative of g in order to answer the question here. So here's g of x. If we want to determine the second derivative of g, we're going to have to first determine what g prime is. So g prime of x, how are we going to take the derivative of this? Now there was this result that we looked at earlier in the year, second part of the fundamental theorem of calculus. We looked at it as a derivative formula, and it let us take the derivative of functions that were defined a lot like how g is defined right now. If we take the derivative with respect to x of a definite integral, and x is actually the upper limit of integration, our result is going to be the same function that's in the integrand here, but with that upper limit of integration replacing the t. So it basically says that derivatives in definite integrals undo each other. They're inverses of each other. If we want to apply this derivative formula, this result, the second part of the fundamental theorem of calculus, to the function g, g prime of x is going to be, well, take the x, put it in place of t, and g prime of x is going to be f of x. If we want to take g double prime of x, g double prime of x is going to be, well, the derivative of the left is g double prime, the derivative of the right is f prime. So g double prime corresponds to f prime. Since g double prime corresponds to f prime, and we're looking at a graph of f right here, we can determine the sign of f prime of x by looking at the slopes of the tangent lines on the graph of f, right? F prime is going to be given by the slope of the tangent line anywhere on this graph. So what we can say, since g double prime equals f prime, g double prime is positive anywhere f prime is positive, right? So this implies that g double prime of x is greater than 0 at all values where f prime of x is greater than 0. This is not that difficult to answer based on the graph. We have positively sloped tangent lines from -4 to 2 on the graph of f. So g double prime would be concave up from -4 to 0. I might have said 2 a minute ago. I accidentally said the y value. But from -4 as our x value to 0 as our x value, we have positively sloped tangent lines. Now we have negatively sloped tangent lines on this piece of the graph, but then on the other side of 3, we're back to positive slopes from 3 up until 6. So from -4 to 0, as well as from 3 to 6, the slope of the tangent line to the graph of f is positive, therefore f prime is positive, and since f prime equals f double prime, g double prime is positive on these intervals, and g is concave up on those intervals.